Have you ever stopped to wonder why some volcanoes are these gentle giants, building up islands over millennia, while others are just ticking time bombs ready to blow? Well, today, we're going to dive into the really diverse personalities of volcanoes and figure out what actually makes them tick. Right, and this really is the core question, isn't it? Because the answer, well, it reveals a pretty dramatic truth. Not all volcanoes are created equal, not even close. You've got the builders, and then you have the destroyers. And their whole identity, their entire story, it's all written by what's cooking deep, deep beneath the surface. Okay, so let's start with the absolute basics. On paper, a volcano is just this. It's an opening in the Earth's surface, a vent. But the real story, the exciting part, isn't the opening itself. Oh no, it's about what comes through it. And as you're about to see, the way that all that lava, ash, and gas gets out, well, that makes all the difference in the world. All right, so let's meet them. The best way to understand volcanoes is to break them down into four main types. Seriously, think of it like a lineup of geological heavyweights, where each one has a completely unique style and a signature move. So, first step in the ring, we've got the shield volcano. And its name is just a perfect description, really. I want you to get that image of a pointy, angry mountain out of your head. Instead, picture a huge warrior's shield, just laid flat on the ground. That's our gentle giants. Okay, now look at this. Because all these characteristics you're seeing, they all feed into each other. The secret sauce is the lava's low viscosity. Now that's a key term, but don't worry, it just means the lava's really thin and runny. Think of hot honey. And because it flows so easily, it just doesn't pile up. It spreads way out, creating these incredibly wide, gentle slopes over thousands and thousands of years. This calm, steady process is literally how the entire chain of the Hawaiian Islands was built up from the ocean floor. It's amazing. All right, now let's flip the script completely and look at its polar opposite. When you close your eyes and someone says volcano, this is probably the one you're picturing. The classic, cone-shaped, dangerously beautiful, and, explosive composite volcano. And its secret? Well, as you can probably guess, it's the total reverse of this shield volcano. The lava here has a high viscosity. It's incredibly thick and sticky, kind of like peanut butter. So it can't flow very far at all. It just cools and hardens right near the vent, piling up layer after layer into those steep, iconic cones. But, and this is the dangerous part, that thick magma is fantastic at trapping gases. So the pressure just builds and builds and builds until it simply can't hold on anymore, and boom, you get a violent, catastrophic eruption. Yeah, just let that term sink in for a second. Violent eruptions. We're not talking about a slow, creative ooze of lava here. No, this is raw, untamable power. We're talking about explosions that can literally reshape entire landscapes and blast ash clouds miles up into the atmosphere. So when you put them side by side like this, the crucial difference becomes crystal clear, right? It all boils down to the lava's viscosity. But what determines that? Well, the answer is a single ingredient, silica. Magma that's low in silica has low viscosity. It's runny and it creates those gentle shield volcanoes. But magma with high silica content, it's got high viscosity. It's thick and sticky, and that's what creates the explosive composite volcanoes. Just think about that. That one ingredient, silica, basically dictates the volcano's entire personality, from its shape all the way to its explosive power. Okay, but the story doesn't just have these giants and titans. Our next two key players are often a lot smaller, but trust me, they have fascinating personalities all their own. So let's meet the cinder cone. You can see right here, cinder cones are basically the sprinters of the volcanic world. They're not really built from flowing lava. Instead, they're built from what are basically fire fountains. Little blobs of gas-rich lava get shot into the air, they cool down into cinders, and then they fall back to Earth, piling up right around the vent. This is what creates that classic, steep, almost perfectly symmetrical cone shape. A great example is Paricutin in Mexico, which famously just grew out of a cornfield back in 1943. They erupt with this crazy intensity, but only for a short time, maybe a few weeks or months, and then poof, they just go quiet. And our final personality is, well, it's maybe the most deceptive one of all. Meet the lava dome. And you really can't let its smaller size fool you. This isn't some majestic mountain. It's much more like a dangerous, slow-growing plug. So what's happening here is pretty wild. The lava has an extremely high viscosity. We're talking so thick and pasty it can barely even move. It just kind of oozes out and piles up right on top of the vent, forming this really rugged, craggy dome shape. So, what's the danger? Well, as it slowly hardens, it acts exactly like a cork in a bottle. It plugs up the volcano's plumbing, trapping a huge amount of pressure from all the gases down below. And if that pressure finds a weak spot and blasts its way out, the result can be one of the most violent explosions you'll find in nature. Okay, so a volcano's shape, its personality, that's a huge part of its story. But it's not the whole thing. There's another really important classification we need to talk about. Its current life stage. Is it active? Is it just taking a nap? Or is it retired for good? Yeah, this is the volcanic life cycle, and it's actually pretty straightforward. An active volcano is either erupting right now or showing signs that it might erupt soon. A dormant one is basically sleeping. It hasn't erupted in a long time, but geologists think it still has the potential to wake back up. And then you have extinct volcanoes. They've been completely cut off from their magma source. Their fiery life is officially over. So, we've met our four main personalities, and we get their life stages. Now let's just pull back for a second and look at the big picture. So, what's the big takeaway from all this? I think it's just how incredibly diverse that single word volcano really is. From the gentle island builders to the explosive, angry peaks, it all comes back to the chemistry happening deep inside the earth. Remember that silica? The amount of silica in the magma determines its viscosity, and that viscosity writes the entire story of the volcano sitting on top of it. Every single one is a unique expression of our planet's inner fire. And that leaves us with one last really cool thought. The next time you're out and you see a mountain, don't just see a big lump of rock. Look closer. Ask yourself, is its shape telling a story of quiet, steady creation? Or is it telling a story of violent, explosive power? Because now you actually know how to read